Hello everyone. Today we are going to discuss about Dalton's law of partial pressures. So in this Dalton's law of partial pressures, what it is talking about, when two or more non-reacting gases have been placed inside a vessel, so then the total pressure exerted by the gas molecules inside the vessel is equals to sum of their partial pressures. So what does it mean is when two or more non-reacting gases, let's take this is the vessel, so we have placed two or more non-reacting gases. Let's take two types of gases we have placed. So this cross is one type of gases and these dots are another type of gases. When these two non-reacting gases have been enclosed inside this vessel, then what is going to happen? The total pressure exerted by the gas molecules in this vessel, that is equals to sum of their partial pressures. So what does it mean? That means when two non-reacting gases have been enclosed, so the total pressure which is they're going to exert, that is equals to sum of their partial pressures. Here 2 points we have to understand. One is non-reacting gases, another one is partial pressures. So we know that when two gases are non-reacting, especially they're not reacting and they're not producing any other compound, so those two gases are non-reacting. First point. Next point, so when these two gases have been placed inside a vessel, so the amount of pressure they are going to produce is called total pressure. So this total pressure, why, how they are going to produce? Because of collisions to the walls of the container, they are going to create a pressure. That pressure is called total pressure in a vessel. So that pressure which is going to be produced in this vessel, that is equals to partial pressures of individual gases. Partial pressures of individual gases means if in the same container, if one kind of gas is placed, if in the same container, if one type of gas is enclosed, if a single gas is enclosed in the same vessel, how much of pressure it is going to exert if the vessel, if the same gas is placed inside the vessel with mixing of another gas, then the same amount of pressure it is going to produce. Again, I'm repeating, what is that? When two or more non-reacting gases have been enclosed inside the vessel, so what is going to happen here? The amount of total pressure they're going to produce, that is equals to sum of their partial pressure. So sum of their partial pressures means, so when the same gas is placed individually, that means here two gases we have enclosed. If the same gases, if you take individually, if they are in the same vessel, so how much of pressure they are going to exert? Same amount of pressure they are going to exert when they have been placed inside the vessel. That means this is, let's take this is first gas and it is having N1 moles. How many moles of gas we have taken? N1 moles. And similarly here, what is going to happen? Another gas we have taken, which is having, what is that? Which contains N2 moles, this second gas. So when these two gases individually, when they are individually present, how much of pressure they are going to exert? That is called partial pressure. So this is P1, this is P2. So this is what their individual pressures. And when these two gases have taken and placed inside a single vessel, and these two gases are what? Non-reacting gases, very much important. Non-reacting gases has to happen. So then when they're placed inside this single container, what is going to happen? The amount of total pressure now they're going to produce is sum of their partial pressures. That means this P total, the total pressure exerted by in this container, that is equals to nothing but P1 plus P2. P1 plus P2. That means sum of their partial pressures. It is talking about, who is saying this? Dalton's. So this law is called as what? Dalton's law of partial pressures. So in this case, so especially since we are focusing on non-reacting gases, especially some gases are there, so they don't obey this Dalton's law of partial pressures. So it do not obey Dalton's law of partial pressures. So who are those combinations of gases who don't obey this Dalton's law of partial pressures? Like we can say ammonia, NS3 plus HCl. These two are what? Reacting gases. They are going to produce as ammonium chloride. So it will not give, or this law is not applicable for these two gases. And similarly, we can write hydrogen and fluorine, H2 plus F2. So for them also, they are going to produce as what? Hydrogen fluoride. So these are what? Reacting gases. So the gases which I'm writing are reacting gases. Third one, we can say H2 plus Cl2. H2 plus Cl2. This is also what? Reacting gas. It is not applicable. Similarly, fourth one, we can see nitric oxide plus oxygen. It is also what? Reacting gas. Similarly, fifth one we can see sulfur dioxide and chlorine, SO2 plus Cl2. So these gases are what? Reacting gases. So that's why this Dalton's law of partial pressures is not going to be obeyed by these gases, because we cannot enclose these two gases. When let's take hydrogen gas and chlorine gas is enclosed, so they vigorously reacts to produces what? HCl gas. So that's why, so these gases is not applicable for Dalton's law of partial pressures, and many times the questions is getting asked from this section. So which gases does not obey the Dalton's law of partial pressures? Then we have to find out the reacting gases don't obey Dalton's law of partial pressures. So which gases they are going to obey? Non-reacting gases. Hope you're getting my point. So in this case, so we are going to see the gas which are going to be generally obtained, how it can applied in the practical applications. We can see generally the gas is obtained or collected through the water. If you see, this is the water. If this is the water, so generally the gas is collected over the water. Let's take this is the dry gas, P dry gas. Dry gas is coming and it is collected through the water by the displacement of water. So the gas, when it is entering into this vessel or collected over water, it will displace some amount of water. So by displacing some amount of water, this gas is being collected. So in this process, what is going to happen? What is the pressure of the gas? What is the pressure we are going to observe? Because the observed pressure will be equals to what is going to happen. So since the gas will also contain, since it is going into the water, it will contain moisture. So that means the pressure is going to be increases. Why the pressure is going to increases? Because the moisture or the water vapors will also contain or will produce some amount of pressure. That is called, the pressure due to water vapors is called aqueous tension. So in this case, the total pressure, what is going to become? So the pressure, the gas which is entering, dry gas which is entering, here it will have pressure, that is pressure of dry gas, plus it is going to experience what kind of pressure? Aqueous tension. So aqueous tension meaning what? It is the pressure produced or pressure due to water vapors. Since the gas is going into the water, so it's already it is having a pressure, that is called pressure of dry gas. And since it is going into the water, so the water is also going to provide certain amount of, because the water contains, or this dry gas contains some moisture. So because of that moisture, it is going to have extra pressure, that is called aqueous tension. So what does it aqueous tension mean? Aqueous tension means pressure of water vapors. So how will you get the pressure of dry gas? This can be written as pressure of dry gas is equal to, what is it? Pressure observed minus aqueous tension. Minus aqueous tension. So this is one of the concept which is linked with, or we can say pressure related with Dalton's law of partial pressures. So this is what the concept of partial pressures. And next important point is how these partial pressures are related to mole fraction. So we can write partial pressures and mole fraction. So if you see, so what is the total pressure you can see? So this is what the total pressure which is exerted by the two gas molecules. So what is the total pressure we can write according to ideal gas equation? Ideal gas equation, we know PV is equals to nRT. So let's take the gas 1. This partial pressure of P1 we can calculate. This gas 1 exerts some pressure. So what is the pressure? P is equals to nRT by V. And how many moles are there? This gas, let's take N1 moles are present. And the temperature, as we are seeing here, we have to keep the temperature constant, and as well as we have to keep the volume constant for all of them. So in this case, P is equals to, this P1 is equals to, for pressure of the first gas, is equals to N1 RT by V. Similarly, for this equation 1 we can write. Similarly, for P2 is equals to N2 RT by V. So this is what equation 2. And when these two gases have been enclosed inside one single container, so the total pressure, what is the total pressure it is going to create? This P total is equals to N1 plus N2 RT by V. Because how many moles are there? When two gases have been enclosed inside a vessel, so P1 contains N1 moles, P2 contains N2 moles. So what is the total number of moles? N1 plus N2 moles RT by V. Now this is what third equation. Now what we have to do is, let's divide equation first equation by third equation. First equation by third equation. What we are going to obtain? So that is P1 by Pt. P1 by Pt. P1 by Pt. That means partial pressure of first gas by total pressure. If you do it, so what is the value you are going to get? N1 RT by V by N1 plus N2 RT by V. So if you do this, N1 RT by V, so V is going to reciprocal, it's going to happen V by N1 plus N2 RT. So V cancelled, RT cancelled. So what we got? P1 by PT is equals to N1 by N1 plus N2. So this N1, this number of moles of first gas by total number of moles is called mole fraction. It is called mole fraction. So in this way, what we can write? So P1 is equals to, what is that? Mole fraction or total pressure. This total pressure is going to multiply. So this total pressure into mole fraction of first gas. So what is the formula we got? Partial pressure of a gas is equals to total pressure of the gas into mole fraction. And similarly for second gas also we can write. And also for second gas we can write for P2 it will be, what is that? P total pressure into mole fraction of second gas. Mole fraction of second gas. So in this case these formulas, these partial pressure formulas, this P1 is equals to P total pressure into mole fraction of first gas. For second gas, the partial pressure of the second gas is equals to total pressure into mole fraction of the second gas. So in this way, these two formulas are very much important to for doing the numericals, and the concept that is very much important. So which gases? Non-reacting gases are, when they have enclosed, then what is the total pressure? The total pressure is equals to, what is that? Sum of their partial pressures. How the questions will be asked? So for when the questions are asking, especially we have to focus on to calculate, what is that number of, what is that, mole fraction. So that when there we have to calculate mole fraction, so our focus should be on calculating number of moles. So how will you get the number of moles? So whether they will be given in the terms of mass or in terms of what, weight. So when they've given weight, so what we can get? How will you get the molar mass? So given weight by molar mass or given weight by molecular mass. When you've done this, so you can get number of moles. Once you get the number of moles of both the gases, then you have to put the values and we can get the answer. Especially when they will ask you what is the partial pressure of the, they will give you the total pressure, and they're going to ask one of the gases partial pressure. How can you do that? So just we have to get number of moles of first gas and second gas, and already given total pressure. So now you can get easily, what is that, partial pressure of first gas. And similarly if they're asking for partial pressure of second gas, and the same thing you have to do it. So since total pressure is given, so our main aim is to calculate mole fraction in this case. And conceptually we have to remember which gases are non-reacting and which gases are reacting. So once you have this clarity, then the questions can be easily solved from Dalton's law of partial pressures. And thank you. And next we are going to see what's called law of diffusion, Graham's law of diffusion, and rest of the kinetic theory of gases and all these things. Thank you.